Hello students, I told you about the alpha particle scattering conducted by Rutherford, and he got some observations. On the basis of observation, he concluded that there is the central part in the atom in which the whole of the positive charge and the mass of the atom is concentrated, and this part is called the nucleus. So now we will find the radius of nucleus and the impact parameter of this one. So size of nucleus. We know that alpha particle is a positive charge and nucleus is also a positive charge. So when a alpha particle directly approaches to the nucleus, it suffers the Coulomb's repulsion. So its kinetic energy decreases, and as a result, its potential energy increases. At the distance of closest approach to the nucleus, the particle suffers 180-degree scattering, and this the minimum distance or the distance of closest approach to the nucleus is called the radius of the nucleus. The alpha particle is positive charge, particle when it directly approaches to nucleus, it suffers Coulombian repulsion. At the distance of closest approach the alpha particle suffers 180-degree scattering. The kinetic energy of alpha particle decreases as it approaches to nucleus, and its potential energy increase. At the distance of closest approach the kinetic energy completely changes to potential energy. So this is the conversion of kinetic energy to the potential energy. So this is like this, that suppose this is the nucleus. This is the R naught. The alpha particle is approaching to it directly. This is the alpha particle. And then at this point it comes back. It suffers 180 degree. So this is the minimum distance of closest approach R naught. The kinetic energy of alpha particle is equal to half mv square. M the mass of alpha particle, m mass of alpha particle, and v velocity of alpha particle. The kinetic energy, the potential energy of alpha particle equal to k z1 z2 upon R naught, where k equal to 1 upon 4 pi epsilon naught. Z1 this is Q1 charge on alpha particle. This is now plus 2e, and Q2 equal to plus Z, the charge on the nucleus. Z the atomic number, E the electronic charge. So this potential energy becomes equal to K and 2Z E square upon R naught. R naught radius of nucleus. So this half mv square is equal to k 2z e square upon R naught, or R naught equal to k z e square 2k z e square upon half n v square. or we can write to R naught equal to 4 k z e square upon mv square. Now it is found that this radius is of order of 10 raised to the power minus 15 meter. It is found that R naught is of order of 10 raised to the power minus 15 meter. So nucleus is very small in comparison to atom. Whose radius is of order of 10 raised to the power minus 10 meter. So nucleus is a very hard part of this atom, and it consists whole of the positive charge and the mass of the atom. The nucleus carries whole of positive charge and mass of atom. So this indicates that the most of the part of the sphere of the atom is hollow. It indicates that most part of atom is hollow. So this is what about the nucleus of the atom. The impact parameter. Impact parameter. It is defined as perpendicular distance between the trajectory of projectile and the center of potential field produced by particle Here particle means nucleus. Nucleus. Defined as the perpendicular distance between the trajectory of the projectile and the center of the potential field produced by the nucleus. So this is like this. Suppose this is nucleus, the alpha particle is here, this is alpha particle, the trajectory of alpha particle is hyperabolic, this is the center, then this is the perpendicular distance B, this is the angle of scattering, scattered alpha particle. So this B is given denoted by B. So B equal to K Z E square cot theta by 2 upon half mv square. Half mv square, the energy of kinetic energy of the alpha particle. Z atomic number, theta the angle of scattering. Where Z atomic number, theta angle of scattering, and half mv square kinetic energy of alpha particle. So this gives you a relation between the impact parameter and the angle of scattering. It is a relation between impact parameter and angle of scattering. Angle of scattering. Now from here we can get some information about the scattering of alpha particle. When B equal to infinity, the cot theta by 2 is equal to infinity. Theta by 2 is equal to your 90, your 0 degree. It means theta equal to 0 degree. It means what, that when the alpha particle is away from the nucleus, they suffers no scattering at all. It means alpha particles away from nucleus passes do not suffers scattering, or they pass and when b equal to 0, it means that cot theta by 2 is equal to 0. So theta by 2 equal to 90 degree and theta equal to 180 degree. B equal to 0 means direct approach to the nucleus. The alpha particle approaching directly to nucleus suffers. Alpha particle approaching directly to nucleus suffers 180 degree scattering. So there are two situations. For b equal to infinity, the alpha particle away from the nucleus, b equal to 0, when the alpha particle directly approaches to the nucleus. In that case, the alpha particle suffers 180 degree of scattering. So this is what that gives us to this one, and you can find that between 0 and 180 degree, if b is not equal to 0, and then the angle theta will be either acute angle or obtuse angle. For b greater than 0 and less than infinity, therefore cot theta by 2 will be greater than 0 and less than infinity. So alpha particles will be scattered at acute angles and obtuse angles. So this is what about the impact parameter, from which we can get some knowledge of the scattering of the alpha particle. So you like this video, share and subscribe, and also share it to your friends studying in the same stream. Thank you.